Okay, we have another problem which is on left tail test. It is claimed that a random sample of 49 tires have a mean life of 15,200 kilometers. The sample is drawn from a population whose mean is 15,150 kilometers and standard deviation of 1200 kilometers. Test this claim as at 5% level of significance. I always suggest the students to draw like this. Whenever whenever you are doing a problem on testing of hypothesis, always make it a point to notate like this. What's been given? The sample is drawn from a population. Population data is being given to me as mu is given to me as 15,150. Okay, just a second. This is 15,000. Okay, yeah. Mu is given to me as 15,150 kilometers. Sigma is also been given, which is 1200, guys. Okay. Now, what else is being given? Sample of 49 tires. So, N is given to me as 49. X bar is given to me as 15,000. Okay. And then no standard deviation of the sample is being given. Directly standard deviation of the population is being given to me. Come on. Let's set the null hypothesis first. H naught would be as it is. Whatever is being given in terms of population, whether it is mean or variance, depending on the question or the test, I'll be setting accordingly. If it is an F distribution test, I'll be setting things in terms of variances. Here, for Z and T distributions, I'll be setting in terms of mu. Okay, mu the mean. Okay. Now, alternate hypothesis should be contradicting the null hypothesis. Now, you see here, X bar. X bar is what? 15,000. Mu is what? 15,150. So, sample mean is suggesting me that mu can be less than 15,150. So, I'll be taking mu less than 15,150. I repeat it again. Sample mean is suggesting me that population mean can be less than 15,150 because sample mean is just 15,000 only. 15,000 is less than 15,150. So I'm setting it like this. Now this decides my test. It is left tail test, guys. Left tailed test. Okay, na? Right. Now alpha is given to me as a 5%. Remaining data anyways I have written pictorially. Right. Now next what I'll do, alpha is given to me as 5%. What it means? 0.05. Okay. Now n is being given to me as 49. Since it is greater than 30, I'll be choosing, I will write like this. This is how I'll be representing, nothing more, nothing less. We choose a Z test statistic. Okay. We'll be choosing Z test statistic. Okay. Yeah. So what's the form? Okay. I will also show the region in which, the rejection region is there, where the acceptance region is there. Okay. Since it is left tailed, my rejection region would be towards the left side. Okay. How will I find it out? 5% now. 5% means what? 0.05 is my rejection region. 0.45 is my acceptance region. What is that value of Z which has the area 0.45? Let me look at the table, guys. 0.450 is there at 1.65. Usually Z alpha can be given in the question. Multiple values of Z alpha can be given in the question. Otherwise, also you can choose it very easily once you have the table with you. Z alpha is equal to 1.65. Mind you, guys, left side would be negative values, right side would be positive values. So it is minus 1.65. What is the Z statistic? Let us see here. Z is equal to X bar minus mu by sigma by root n. Sigma has been given, so I can consider accordingly. Okay, so X bar is what? 15,000 minus 15,150 by sigma is given to me as 1200 by root n is root 49, which would be 7, guys. Actually, when I was explaining, one of my students said Ma'am, whenever there is a negative value of Z calculated, we can choose left tail. Accordingly, afterwards, after Z is calculated, I'll be writing my alternate hypothesis. If it's a positive value of Z cal I get, I'll be choosing right tail, he said. That was also a valid point. You can go that way as well. Okay. So now this gives me what? Minus 150 by 1200 into root 49 is 7. Accordingly, you will calculate the value. Let me find the value once. Okay, once you calculate the value, what I should do? Any value less than minus 1 point. Let me write here. If Z cal less than Z tab means what? Z tab, which is equal to minus 1.65. All the values less than minus 1.65 would be towards the left, guys. Why? Because negative values, as the number increases, its value decreases with a negative sign, right? Okay. So what's this value? Into 7. This value turns out to be 0.875 with a negative sign. Okay, guys, with a negative sign. So minus 0.875 is definitely greater than minus 1.65. Or this value, whatever is there, would be somewhere here in the acceptance region only. Okay, so what's happening? Z cal is greater than Z tab. If Z cal is than Z tab, reject H naught is what I should do. Okay, reject H naught. But in this problem, what happened? But here I will say Z cal is equal to minus 0.875, which is greater than minus 1.65. It's greater or less. You can just see if you plot the Gaussian curve, guys, the normal distribution curve or the Z curve. Okay, accordingly, you will realize the shaded part is the rejection region, the non-shaded part is the acceptance region. So if the value that is calculated comes into acceptance region, accept H naught. If it falls in rejection region, reject H naught. That's it as the conclusion. But hence Z cal is greater than Z tab. We accept H naught. Okay, don't write this above sentence. It is only for your information. You need not write that in the exam. Whatever is the conclusion, that is Z cal greater than Z tab, we are accepting H naught is the only point that you will write. Also, you will say that is mu is equal to 15,150 kilometers or minutes or whatever you will write at alpha is equal to 5% level of significance. At a different level of significance, you can reject as well. But with 5% level of significance, I am accepting. Okay. You can just see here, guys, mu H naught, I have set it to be in terms of mu is equal to 15,150. Okay. That's how I will write an answer. Nothing more, nothing less. Okay. Look at the table, get the value. In case tabular values are given in the question, then your job will be very easy. So accordingly, pick up the value that you need and proceed with the problem. This is how you will do a left tail test. Let's discuss two tail test in the next video.